Welcome back, friends. Dan Vega here, your friendly neighborhood Spring developer advocate. And today we're going to be talking about securing your REST endpoints using JSON Web Tokens and symmetric key encryption. Now, what the heck just came out of your mouth, Dan? I know, I said the same thing. But what we're going to do is kind of break this down for you. So in a previous tutorial, which I will link up here and in the description below, we did this. We secured our REST endpoints using JWTs and something called asymmetric encryption. So there's asymmetric and symmetric. What's the difference, Dan? We are going to be using Spring Security's OAuth 2 resource server, which utilizes cryptographic signatures to validate the tokens. This simplifies a lot of things because you can eliminate the need for some separate authorization server. So this is great. So we have asymmetric and symmetric. So asymmetric, which we used in the previous tutorial, uses two different keys. It uses a public and a private key. One to go ahead and sign the token, and then one to go ahead and validate the token. In a symmetric key, we only have one single key. The same key is used to both sign the token and validate the token. This, as you can imagine, is a little bit faster and a little bit simpler. So when would I want to use this, Dan? Well, let's just say you have a simple application. Maybe you have a SPA front end and a single backend. We're not trying to replicate this backend over instances. We have no sessions or therefore sticky sessions. This is a great use case for that. Again, it's a little bit easier. One key. We don't have to deal with generating these different public and private key pairs. So it just simplifies a lot of things. So how are we going to accomplish this today? I'm going to walk you over to the GitHub repository. This will have all the final code in it. If you want to go ahead and check that out, you can. But we are also going to build this from scratch. We are going to start a new Spring Boot 3 project. There have been some changes if you've been paying attention to this channel in Spring Security 6. So we'll take a look at those changes as we start to build out our security configuration. So this is something that you guys have been asking for. So I really hope you enjoy that. And with that, let's dive into the tutorial. All right, so the first thing is if you want to grab the completed source code, you could head over to github.com/danvega jwt-symmetric-key. Here, there's some information about the tutorial that we're going through today, as well as how to run the application, and a quick thank you and shout out to my friend Daniel Garnier, who really helped me on this particular tutorial. So go ahead and check that out. But if you want to follow along, you can build this with me. We're going to start every project like we do over at start.spring.io. I'm going to choose a Maven project. I'm going to use the latest version of Spring Boot, which is 3.0.1 at the time of this recording. I'm going to go ahead and set a group of dev.danvega. We'll call this JWT Symmetric Key. And this is a JWT demo using symmetric key encryption. So that looks good. We're using jar, we're using Java 17, and then we just need a couple of dependencies. So I'm going to choose Spring Web. And also you might think to go ahead and grab Spring Security. We actually don't need to grab Spring Security because we're going to pick the OAuth 2 resource server. And if we go do a quick explore here, we can say, we can actually jump into this one here. I can do that in the pom.xml once we get into the project, but you'll see that that actually brings in the Spring Security dependencies that we need. So this is really all we need to get started. So what I'm going to do is go ahead and generate this. It's going to download a zip file for me. I'm going to open this up in my favorite IDE, IntelliJ IDEA. You can open it up in whatever IDE or text editor you are most productive in. All right, so I'm going to start this tutorial by taking a look at the POM. Again, I mentioned before, we have the Spring Boot Starter OAuth 2 resource server. If we go ahead and jump into that, we can see that that brings in things like Spring Boot Starter, Spring Security Config, Spring Security Core, the resource server, things like OAuth 2 Jose. So there's a bunch of stuff in there. So all the dependencies that we need, we brought in by just choosing that OAuth 2 resource server. So the first thing that I want to do is actually go ahead and create a couple of classes. Let's start with a controller. So I'm going to create a new package. I'm going to call this controller. I'm going to create a new Java class in here. I'm going to call this home controller. At the end of the day, this is going to be a REST controller. I need a class that I can go ahead and test. I want to be able to get to this endpoint but I want it to be secure. So let's talk about this. So I'm going to create a new get mapping in Spring Boot 3. I need to go ahead and be explicit about that. So I'm going to say get mapping /. I'm going to say I want this to return a string. And I'm going to eventually get the principal. So I want to get the authentication. So from Spring Security Core, authentication. And what I can do is just return a message that says hello, and then we'll use the authenticated principals get name. So once I have that, this is what I want to secure, right? We need to start somewhere. We need to secure this. The way that I'm going to do that is I'm going to create a new package, and I'm going to create a package called config. Now, the reason we're doing this is if we go ahead and start this application up now, by default, because we have Spring Security on the class path, because we have not overridden the default security out of the box, we are getting some defaults for us, right? Everything is locked down by default, which is a good thing. We also have a default user with a username of user and a password that is randomly generated. Now, this is great for just kind of testing things out, but what I want to do is set up my own security config. So to do so, I'm going to create a new Java class, and we're going to call this security config. And inside of here, this is going to be a configuration class, and we are going to enable web security. The first thing I'm going to do is I want to create a user that I can use in this system to test out. So we are going to start by creating an in-memory user. Now, I get this question all the time, and I understand the frustration. Dan, why do you use an in-memory user? Why do you use HTTP Basic? And the reason for that is to keep these tutorials nice and concise. If we did all of the things that everybody needed to do in some of these security applications, these tutorials would be really long and nobody would watch them. So what I'm saying here is we're using an in-memory user, but I have other tutorials. You can find other tutorials on YouTube or on the web on how to replace that in-memory user with something you grab from a database. So I just need a user to test out here. So I'm going to create a new bean. This is going to be of type user details service, and we'll call this user details service. And all we're going to do here is return a new in-memory user details manager. And what we're going to do is we're going to call user.withUsername. So the username that I want for this is going to be dvega. We're going to set a password. So we need to figure out how are we going to do encoding on the password. We normally don't want to store plain text passwords, right? In this case, we don't care about that because it's an in-memory user. So you could set up a password encoder, or right here in the string, you can just use these curly brackets and then define the encoder. In this case, I'm saying I don't want a password encoder, just use the plain text of password. So now I have a password. I also need to set some authorities. So this user is going to have an authority of read and a role of user. We'll talk about more while we have both of those there in a little bit. And finally, I'm just going to build this. So because I'm going to build this, this is going to, no, we want to, let's just do this right here and return that. So now I have a user. Good. Off to a good start. I have a user in the system. Now I need to override that security configuration. I've done other videos on this in the past. We used to go up here in our security config and extend something called the web security configure adapter. Rolls right off the tongue, right? So you see that that's not even an option anymore as of Spring Boot 3. That has been deprecated and removed, so you can't even do that anymore. And what we do now is we've moved to a more component-based model of this. So the way that we're going to do this is we're going to define a new bean, because again, this is a configuration class. And we want to return a bean of type security filter chain. So we're going to say security filter chain, and we'll call this security filter chain. And this takes an argument of HTTP security. There we go. We'll call this HTTP, and we're just going to return whatever the HTTP build method returns, and this is going to throw an exception. So now that we have that, we can start to define our security config. And what is this going to look like? So first off, I'm going to go ahead and disable CSRF. So we're going to say CSRF abstract. What is it? Abstract HTTP configurer. That's the one I wanted. And we're just going to disable that. And then I'm going to use authorize HTTP requests. So again, we might have used authorized requests in the past. Now we're on Spring Boot 3, Spring Framework, Spring Security 6. In Spring Security 6, authorize requests has been deprecated. We want to go ahead and move to authorize HTTP requests. So we're going to get auth here, and we're going to say auth. And then I want to go ahead and say any request that comes in, you must have the authority of scope read. So we'll talk more about that in a second, but we're basically saying no matter what the request is, somebody who, if you're trying to hit an endpoint in our system, you need to have this authority. Otherwise, we are going to turn you away. You're going to be unauthorized to access that. So far, so good. I'm also going to set up session management here because we don't need sessions. So I'm going to say session.create session policy, session creation policy. We're going to say this is stateless. So we're going to pass that in. Then I'm going to go ahead and set up my auth2 resource server. So we'll talk about this in a second. Again, I've covered this a little bit in more detail in the previous tutorial that I mentioned at the open of this and also in the GitHub repository. So if you want to kind of dive into this a little bit more, you can. But all we're doing here is we are saying that we are going to use the built-in JWT support. I need a way to log in. I need an authentication mechanism. Again, I'm going to use HTTP basic here. So if you don't want to use basic, I've got other videos on how to kind of move away from this and use something like username and password authentication with, say, an endpoint. Again, I'm trying to keep this as concise as I can. So that's what we're going to do here. So with all of that, we should be good on the security filter chain declaration here. We have our security. We're saying, hey, go ahead and any request, you will turn them away if they don't have that specific authority. So we know that our dvega and our password username user here does have that authority, that scope. So that's good. We're also using HTTP basic, and then we've set up the auth2 resource server. So now with this HTTP basic, when I log in, I'm going to basically log in with dvega and password, and I'm going to get a role of users. So at some point, once I'm logged in, once I'm authenticated using HTTP basic, I want to be able to get a JWT token, right? So we need to create a way to get a token. So let's pretend we have a token controller. So let's go in here. We'll create a new Java class. We'll call this auth controller. I'm going to create a REST controller here. This is going to have a request mapping of /API/auth. And then inside of here, we may have a post mapping where you say to /token. I'm going to pass in some authentication, and I'm going to get a token back. So authentication, go ahead and return to me some kind of token, right? So the next step is, okay, we need a way to generate this token, but we kind of skipped something here. When we define this auth2 resource server, in here, let's go ahead and download this. It's basically saying that when we do this, we need to define, where are we? So when we are in the JWT customizer, When we're in here, we need to, so this enables our JWT encoded bearer token support. So now we get this JWT support out of the box, which is great. But when we do that, when we use the JWT customizer, we need to do one of the following. And one of the following is expose a JWT decoder bean. So we need an encoder and a decoder. So we talked about in the README, we talked about the fact that we are using symmetric key encryption. This means that the same key is going to be used to sign the token, and the same key is going to be used to verify the token. So we have one key used for both. So what is that key? We actually need to set that up, right? So we need a JWT key. Let's see right here if this is the one I was looking for. Yep. So I'm going to set a property called jwt.key. This key can be just a random string if you wanted to. At any case, for the example that we're working on, it must be at least 256 bits. So I generated this random 256-bit key, but you can just put out, if you just want to write in some random string, you can just make sure it's 256 bits. So we have this key in here. We want to be able to go ahead and pull that into our security config. So right at the top of my security config, I'm going to go ahead and say private string JWT key. And we'll go ahead and get this using the @value annotation. And so in @value, we'll reference this by saying jwt.key. And we'll save that. And we should be good to go there. So now that we have this in place, we can create an encoder and a decoder. So a way to basically encode the signature of the JWT, and then a way to verify that signature of the JWT. So I have a couple shortcuts here. We don't want to watch me kind of type this out. So I have an encoder and a decoder. So the encoder is going to return that Nimbus JWT encoder, which is a part of the resource server. When we bring in kind of like the Jose stuff, we get all of this part of that. So now in a previous video, we used something different. When we use like a public key, right? We had a public key and a private key. Here we're saying, instead of a public or a private key, you're saying, hey, I'm going to have a new immutable secret, and we're going to pass in that key, and it actually needs to take in a byte array. So we're just going to turn that string into a byte array by calling get bytes. So now we have an encoder. Now we need a decoder, and this is where some things get a little tricky. So I have to create a new secret key spec. So this is part of the javax.crypto.spec. So some of this stuff is kind of new to me. Maybe it's not new to you, but this is where this was a little tricky for me. So you have to set up a secret key spec, and with that secret key spec, now you can go ahead and pass that into with secret key. It's not as easy as just saying, hey, let me pass in a string. You need to set up a secret key spec. Then we need to define the algorithm that we're using. In this case, I want to use the same algorithm that I'm going to sign with as the same algorithm I'm going to decode with. So we haven't signed our JWT yet. This is just the encoder that we're using. When we go ahead and create a token service to sign that signature, we will go ahead and use the same MAC algorithm. So we're using MAC algorithm HS512. So that is the encoder and the decoder. So we're almost there. With that in place, we can go ahead and create a new package. We'll call this service. I'm going to create a new Java class called token service. And inside of this, I'm going to say this is a service. And inside of here, I'm going to get an instance of that JWT encoder because, again, if we go back to here, this is a bean. So we know that it is now in the application context. So I can ask for it in a component like any other class. So I can say private final JWT encoder, JWT encoder. Actually, let's just call this encoder. And we can get this through constructor injection. So once I have the encoder, I can create a method that will generate the token. So we're just going to kind of put some code in here so we don't have to walk through all of this. Let's go ahead and see if we can't get these imports in here. Okay, so now we have these in here. Let's take a look at this code and find out what's going on. What we are doing here is we are getting an instant for now. We are setting the scope. So the scope is for the permissions, like the authorities that we care about with the user. So what we're going to do is we're going to map whatever's coming in to a granted authority. Now we're not mapping anything that starts with role, so we're kind of filtering those out. And the reason for this is when somebody logs in with HTTP Basic, they're assigned this role of user. And we don't care about that. What we care about is the authority of scope, because we want to assign that user this authority, and that is going to be what's in the JWT token, right? So we want whatever's in the JWT token, the scope of read. That's what we're checking for in our Spring Security config when we're saying, hey, go ahead and lock down any request and make sure they have an authority of scope read. Because if we just said user role or role user, they get that when they log in with HTTP Basic. So then the JWT is really kind of pointless, right? So what we're doing is checking that JWT for a scope of read. So we're doing that, we're collecting that, we're setting up a claim set. So the issuer is self, I'm self-issuing this. It's issued at now, it's gonna expire 1 hour from now. Here is the subject, here is the claim, that is the scope that we've created. Go ahead and build that. Finally, in a previous version, we just kind of passed the encoder and return the token value, but we need to set up some encoding parameters when we're changing the algorithm that we're using. So I set up these encoded parameters. So we're saying JWS header with MAC algorithm HS512 to match the one we are decoding with. We pass that into our encode method, and that returns a token. So far, so good. Now, the only other thing here is that we do have this auth controller, right? And we need to return the token. So we need to get an instance of that token service. So I'm going to say private final token service, and we'll get that through constructor injection. And then what I'll say is token service.generate token, and we'll pass in our authentication. All right, so with that in place, we have this last endpoint that we need to do a little configuration for. So if I go into here and I say, I want to go ahead and use request matchers and say anything to /API/auth/token. To go ahead and access that, you must have the role of user. And so now we know that this particular user, this in-memory user, has a role of user. So when you log in via HTTP Basic, you'll have this role of user, so you'll have access to it. And then once you get here, we have our authentication. We are now authenticated via HTTP Basic. We have that authentication. We can pass that to the generate token method. We use that get name, which in this case is Vega, and we build out our JWT token. So I think we are good. Let's just double check everything we have. So let's talk through this. We have our security config. We have a home controller. So if we access localhost 8080 when this starts up, we should get it unauthorized. We have another controller endpoint that allows us to get a token, but we can't get a token unless we pass in some basic auth parameters, because that's what we're using here. Once we do that, we should get back a JWT token because we are generating that using the token service, and we have our encoder and our decoder here. We're using the built-in OAuth 2 resource server along with the JWT. So that should just go ahead and check that JWT token and allow us access. So I think that everything should work. Let's go ahead and cross our fingers. We're gonna restart this application. And it looks like that started up. So let's do this. Let's head over to Postman and see if we can test this out. All right, so I'm in Postman. I'm going to make a GET request to localhost 8080. I have nothing in the authorization. So normally we'd pass a bearer token, but we don't have one yet. So this is the first run. I'm going to go ahead and hit send. And yes, we are indeed getting a 401 unauthorized. So now what we want to do is we want to create a post request to localhost 8080/API/auth/token. We need to pass in our user credentials. This is real easy in Postman. If you go over to authorization, select basic auth, and then choose your username and password. Let's go ahead and put in a bad password first, so just something that doesn't work, and go ahead and click send, and we are still getting a unauthorized. So now if we go ahead and put in a correct password and click send, we are indeed getting the token back that we expected to get back. Now that we have that token, we can go over to our GET request and choose authorization type bearer token. Because again, that's what the OAuth resource server JWT setup we did in the security config enables us to do. It gives us that JWT bearer token support out of the box. So now we're passing in an authorization of bearer token. Here's my token. Go ahead and click send, and indeed we're getting the welcome message, hello, and then the username, and we have a 200. So wow, that was a lot. I know that was a lot. There's a lot of steps in this, but I wanted to kind of, I didn't want to drag this out. I wanted us to get through this pretty quickly and at least see an example of this. So this is really in contrast to what we talked about in a previous tutorial with asymmetric key encryption. We have a public and a private key. Now, those are great for certain scenarios. There's a little bit more work involved, right? Like you need to understand how to generate those public and private key pairs. You need to know that that private key should not be checked into Git and stored anywhere, right? In this case, I have the same key that I just have in my application.properties and that I'm using to go ahead and sign the signature and verify the signature as well. So again, this could be a value, so this is an example that I'm using in dev. So in a production real world scenario, this may be some type of key that I rotate. So you could use some type of a different way to provide this value. This may come through some type of environment variable or configuration, or through some like secrets manager, depending on, how you're kind of deploying to production. So cool. I think that's it. I really hope you enjoyed this tutorial. If you found some value in this, do me a big favor, friends. Go ahead and click that thumbs up, subscribe to the channel, and as always, happy coding.